Can you build a strong bridge using only paper and tape? Sounds like a school science project, right? But what if I told you? Paper bridges have actually been tested to hold hundreds of kilograms. What if I told you that NASA, the military, and even top architects are experimenting with paper-based structures? Welcome to another jaw-dropping episode, where we don't just ask big questions, we bend the limits of what's possible. The science of paper. Let's start with a simple truth. Paper isn't weak. It's made from cellulose fibers, tiny but incredibly strong at the microscopic level. Think of them like microscopic steel rods packed tightly together. Paper actually has excellent tensile strength, and when it's folded or layered the right way, it can handle weight like a champ. That's exactly why origami designs are now being studied by aerospace engineers. And here's a fun fact you'll love. If you fold a single A4 sheet 12 times, in theory, it becomes thicker than the Burj Khalifa. Sounds wild. Well, math doesn't lie. The engineering behind paper bridges. Here's the engineering secret. Structure beats material. That means we're not just laying paper flat. We're folding it into triangular trusses, arched supports, and corrugated patterns, all inspired by real-world bridge designs, from the Golden Gate to next-gen Martian habitats. Cool fact. Students in Japan once built a paper bridge that held over 1,000 pounds just by layering, folding, and using smart geometry. No glue, no tricks, just pure design power. Real-life case study. Japan's paper house. During World War II, Japan faced a shortage of building materials. That's when architect Shigeru Ban stepped in with a bold idea: paper tube houses. These weren't flimsy huts. They were strong, earthquake-resistant, affordable, and surprisingly sustainable. Fast forward to today, and Ban's paper structures are being used to build refugee shelters in disaster zones around the world. Yes, paper is saving lives. Futuristic twist: space bridges. Made of paper? Now let's blast into the future. NASA and MIT are developing origami-based structures that can fold inside tiny spacecraft, then expand into massive habitats once they reach space. Guess what material they're experimenting with? Ultra-thin, bioengineered, cellulose-based paper. Yeah, paper, but made for the stars. On Mars, weight is everything. That makes paper-like materials perfect. They're strong, lightweight, and foldable. All the qualities space engineers dream of. A paper bridge on Mars? Not impossible, just not built yet. Try this at home. Paper bridge challenge. Still not convinced? Here's your DIY experiment. You'll need 10 A4 sheets, some masking tape, a couple of books for support, and maybe a brick. Now fold the papers into triangular beams, tape them into a truss structure, and place it between the books. Start stacking weight, book after book. Then try a brick. You'll be amazed how much it holds. That's not magic. It's science, engineering, and a little bit of get-set-fly spirit. So the next time someone says, paper is weak, just smile and say, it's not about the paper, it's about how you use it. This isn't just about bridges, it's about life. Even the simplest things, arranged the right way, can carry the heaviest burdens. Can you build a paper bridge that holds more than your school bag? Try it. Break limits, bend science. Until next time, dream big, think smart, and get set fly.